assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So based on Coulomb's law, the energy of our lattice should be, let me not put equal, it is proportional to, so that alpha means proportional to, the charges of the two pieces we're putting together divided by the distance between the two pieces. And so we can also say that that's about the charges divided by the distance between our two substances can be thought about as the radius of each. Okay, and we add them together. Okay, so the radius of the first one plus the radius of the second one is essentially the distance between the nuclei. And so if we're looking at something like CsF versus BaO, a couple things I want you to look at. Charges, there are Q's. Q stands for charge. Okay, so Q1 and Q2 are charges. So the charge of cesium is +1, and the charge of the fluorine is -1. For our barium oxide, it's +2 and -2. Okay, so if we were to look at CsF, Q1 times Q2 is 1 times -1 or -1. Q1 times Q2 for barium oxide is 2 times -2 or -4. So actually, based on charge, BaO is going to have 4 times the energy, right? 2 times -2 versus 1 times -1. Okay, then our cesium fluoride. Now, if you look at the distance between them, let's look at the radii. Because there is a difference between the cesium radii and the barium radii, but they're both in row 6. They both have 6 electron shells. So their radius really isn't that much different. O and F both have 2 electron shells, and in fact they're right next to one another on the periodic table, just like cesium and barium are. So in a row, if they're right next to one another, they don't have a large difference in radius. So even though R1 plus R2 will be different for each of these, they are not that much different. And that means that our Q1 and our Q2 are going to play the major factor in energy. And that's backed up by the values. The lattice energy of CsF is -744 kilojoules per mole. And the lattice energy of BaO is -3029 kilojoules per mole. We said that the BaO is going to be 4 times larger just based on charge. And so if we took this -744 and we multiplied it by 4 times greater, we wind up with -2976 kilojoules per mole. And you can see that then, you know, those numbers here are roughly, right? Not exactly, but they're roughly equal. And so the difference between these two numbers now has something to do with the radii, but mainly it has to do with the charge.